All right. Well, this is the second chapter, kind of in a sequence of two chapters, where we're talking about collecting data and what can we do with it. So in chapter 10, we were talking about sample surveys and how we can collect data, how we can get a good sample, a good random sample, minimize bias and that kind of thing. And so in this chapter, chapter 11, we're going to talk about what do we do with that once, what do we do with that data once we get it? And so let's start with an example. And so this says a study was conducted at Mission Viejo High School in California on the relationship between music and academic success. Researchers compared the scholastic performance of music students with that of non-music students. The music students had a higher overall GPA than non-music students, 3.59 to 2.91. Not only that, 16% of the music students had all A's compared with only 5% of the non-music students. Parents and teachers have argued that music helps students through their work ethic, discipline, and feelings of accomplishment. Those skills then translate into scholastic performance. So this is an observational study. It is not an experiment, and we'll talk about why. So the study compared GPAs of the music students and the non-music students at high school. The results, we had 3.59 music student GPA versus 2.91. And then 16% of all the music students got A's, all A's, where the 5% of the non-music students did. So, so a conclusion we might ask, or a question we might ask, should we just make all students play an instrument? And reason being, or the kind of the logic behind this is, if all students played an instrument, would all GPAs go up? So would that automatically make GPAs go up? And then you might, we could think of possible reasons why that may be the case, why it may not be the case. So could there be something else resulting in both? For instance, perhaps all the students that were in the music program have easier classes, and maybe that's the difference. And maybe it's not the instrument itself, it's just the class load for the music students versus the non-music students. Maybe it's parental involvement. Could be a number of things. And so the problem with the observational study is that there's no way to tell what those things might be. So we'll talk about how we might be able to fix that as we go along. So this is an observational study. Like I said, in an observational study, researchers do not assign choices. They passively observe the participants. This is good for discovering relationships, but it's bad for establishing cause and effect relationships. So kind of think about when we've talked about scatter plots, you can see a relationship between two quantitative variables, but you can't say that one is causing the other to move in the way it's moving. And similarly with scatter plots, these are tough for handling lurking variables. So kind of like I said, do musicians have more supportive parents that help GPA? Or smarter people more inclined to play an instrument? Maybe, maybe not. But you can't look at an observational study and make those determinations. So that's one limitation for the observational study. What about with experiments? Is it possible to establish a cause and effect relationship? So if we want to turn this into an experiment, so this music GPA versus non-music GPA, how would we turn that into an experiment? So we can get 100 kids at this high school or elementary, whatever it is, whatever school. And instead of letting them choose whether they want to play an instrument or not, randomly pick 50 of them to be in the music program. And then the other 50 are not allowed to be in the music program. They're not allowed to play an instrument, that kind of thing. So an experiment requires, and let's underline this, an experiment requires random assignment of, that was terrible, random assignment of subjects to treatments. Only experiments can establish cause and effect. So how experiments work. Now, this is kind of where we get into the crux of this chapter. So just like the last chapter, there's no math here. but there are a lot of vocabulary words. And if you don't know what these words are referring to, then it's going to be very difficult to kind of parse what we were talking about. So the first thing we need to do is we need to identify explanatory variables. We're going to call these factors. So when we talked about scatter plots, the explanatory variables was the x variable. It's the one that you're going to try to make a prediction. It's the one you're using to make a prediction on the other variable. The other variable is called the response variable. That's what we called it in the previous, or in the chapter 6 with the scatter plot. And we're still going to call it the response variable. So we're going to use the explanatory variables, or the factors, to make a determination or a prediction on the response, or see if there's a correlation there, and then possibly see if one is causing the other. Select the subjects or participants. If they're human, that's what we call them, or experimental units if not human. So this is going to be the who. If you remember from chapter 1, the whatever is the sample, that is the who. And then we'll decide on levels for each factor. So factors, we have to have at least one factor. And then for each factor, you have to have at least 2 levels. So in this case, the music program or the non-music program, those are the 2 levels for the one factor. So everyone would be assigned to play an instrument or not. You're assigned one factor, and then there are 2 possible choices for that factor. And then we could kind of make this more complex. And let's say we assign hours of sleep to every student in this experiment. And so every student would either be assigned to play an instrument or not. Every student would either be assigned 4 hours to sleep, or 6 hours, or 8 hours. So this factor, this is one factor, it has 2 levels. This is another factor that we could add in if we wanted to, and this factor has 3 levels. So every student is assigned one of these 2, every student is assigned one of these 3. So every student is assigned 2 things. And get one of these, and it's random assignment. And that's what makes it an experiment. So we have factors, we have levels, and then the combination of specific levels from all factors that a subject receives is its treatment. And so how many treatment groups would we need here? 2 times 3. So in this, if we do the experiment in this way, there would be 6 treatment groups. So we'd have one treatment group would play an instrument and get 4 hours of sleep. Another treatment group would play an instrument and get 6 hours of sleep. Another treatment group would play an instrument and get 8 hours of sleep. And then we do the same thing with non-music assigned. They divide the non-music program into 3 more groups. We'd have 6 groups altogether. So again, factors, how many things are you going to assign to each person in the experiment? That tells you how many factors. So we have to have at least one factor. And then each factor has a certain number of levels. We need at least 2 levels per factor. So we see 2 levels here, 3 levels here. It doesn't make sense to have 1 level in a factor, because then there's no delineation there. Everyone's getting the same thing if that was the case. So there's no point in doing that. And then the combination would be the treatment. So you have to have at least 2 treatment groups. But a lot of times, if you have more than one factor, you'll have more than 2 treatment groups. But the way you get the number of treatment groups is levels times levels. So 2 times 3 in this case. All right. Now, assigning participants to treatments. Do not let them choose. Do not assign what is best. You randomly assign participants into groups, and then each group receives a different treatment. And again, the treatment groups: music program plus 4 hours of sleep, music program plus 6 hours of sleep, etc. So those would be the treatment groups. So in this example, we have 6 treatment groups, and only 3 random assignment can cause and effect relationship be established. And so we do not have a random assignment in an observational study. So the way the example was in the beginning, where everyone just chose to play an instrument or not, there's no random assignment there, so you cannot establish a cause and effect. All right, so moving on, control and randomization. So control, we want to make all conditions as similar as possible for all of the treatment groups. Control allows us to isolate the one thing that is being studied, helps avoid lurking variables. So anything that you can't control, you should. And essentially, you want the only difference between each treatment group to be whatever it is that you're measuring. So the musical instrument and the hours of sleep in this case. But you cannot control everything. Obviously, you cannot this case with this school high school children. You can't control everything. So that's where the randomizing comes in, equalizes the effects of the variation that we cannot control, distributes the uncontrollable factors equally, reduces bias. So we want to control what we can and randomize the rest. And then we can talk about replicating and blocking. So replicating, we want to apply each treatment to a number of subjects. Obviously, if we have 6 treatment groups, we don't want just 6 people in this experiment. You want a number of people to be in each of the 6 treatment groups. And then after doing the experiment, doing an experiment once is not really indicate a particular conclusion necessarily. You want to do the experiment again on a different population. But normally when we talk about replicating, we're talking about this first part in this class. So apply the treatment to a number of subjects so that one person is not going to get a treatment and then that's going to make any decisive conclusion. And then blocking. So blocking can be a little bit confusing until you get used to it. So we want to group similar individuals together and randomize within each of these blocks. So blocking is essentially, it kind of looks like a factor, but we're not randomly assigning these things. So a lot of times it's going to be things that you are already doing or the person is already doing that's in the experiment. So for instance, maybe smoking it could be blocked. So like you have some you're going to randomly assign some kind of physical fitness program, and you have a group of smokers that are going to do this. You have a group of non-smokers that are going to do this, and then you have a couple of different programs. So maybe you just divide people up by whether they're smoking or not already, and so that would be a block. You're not. Whereas the difference between a block and a factor you would randomly assign people to smoke or not as part of your experiment. With a block, you just see that this group of people are smokers, this group of people are not smokers, and you divide them up in that way. So that would be a block. So the difference between blocks and factors look alike. They look similar. The difference is a block is not randomly assigned. A factor is randomly assigned. So divide people up by what they're doing already. That would be a block. So for example, is pet food safe? How can we implement control, randomization, and replication control? So food and water proportions, housing, exercise, sleep, stick to one breed, randomize, assign dogs to 2 feed treatments randomly, and then replicate, redo the entire experiment with a different breed. So we'll get into a little bit more on the next video, but that's enough for this one. So if you have any questions, feel free to email me, and I will handle those.